I have the pleasure to introduce a friend and colleague who is one of the shining lights here on our campus. He started out at Oxford University, where he did his undergraduate work in physics. So he's a real physicist. And then he went on to get his PhD from Stanford, and he joined us here at Berkeley, where he has served as a professor in the Department of Computer Science. He's currently the Smith-Zadeh Chair in engineering, in the College of Engineering, and has also served as department chair for the department, which we greatly appreciate. He also has an adjunct appointment in the Neurological Surgery Department at UCSF, and he has a number of other achievements. He won the IJCAI Computers and Thought Award. He's an ACM Fellow, AAAS Fellow. He also holds the Blaise Pascal Chair, I believe, in Paris. He's on the advisory board of the, this is most relevant to what I'll be talking about today, and you've probably seen him quoted in a number of press reports about the issues about the advances of AI and imminent potential dangers of AI. And he's on the advisory board of the Center for the Study of Existential Risk, which is an international body, and also serves as the vice chair of the World Economic Forum's Council on AI and Robotics. My favorite position that he has, though, however, is that he is the co-founder of the Berkeley Artificial Intelligence Research Lab, which is brand new. It's known as BAIR, B-A-I-R. And he has a Stephen Hawking number of 1. Please join me in welcoming Stuart Russell.
Thank you very much, Ken. I thought Ken was going to mention my extensive service on the Faculty Club Wine Committee, but that's unfortunately come to an end because that committee is oversubscribed with applicants for some reason I don't understand. Okay, so I would try to go through this fairly quickly so we have time for discussion, because I think discussion is very important in clearing a lot of things up. So what are lethal autonomous weapon systems? Sometimes called LAWS, L-A-W-S. You'll see that acronym quite a lot. It's an unfortunate acronym because it conveys exactly the wrong impression of what these systems are like. So they're weapons that can, as some people put it, take the human out of the loop. They can locate, select, and eliminate human targets without human intervention. So that's the formal definition, and these are the things that the United Nations is discussing. A lot of people think of them as science fiction. For a long time, even the disarmament groups were saying, well, of course, these weapons are 20 to 30 years in the future. Why they thought that, I have absolutely no idea, because in simple forms, they've been around for a very long time. Landmines are autonomous weapons in this sense, but they have a degenerate locate and select function. So anything that comes nearby, sometimes they have the ability to sense the amount of metal that's above them, or have some mass, lower limit on the mass. But that's a very simple form of selection, and then they eliminate the human target. And it's precisely for their indiscriminate nature that they have been banned, although the United States has not ratified that treaty. I'll say that a lot in this talk. So in South Korea, on the demilitarized zone, Samsung has built sentry robots for South Korea, which look like this. They have a machine gun and a camera, and they can locate people moving through the landscape up to 2 miles away. They operate either in human supervised mode, where they first alert a human guard to approve the attack, or they can be in autonomous mode where they can just attack the human target without intervention. Israel has a missile called Harop or Harpy or various other names, and several versions of this exist with other militaries around the world. It looks like that, so it's about 20-odd feet long. It can carry pretty heavy payload. It has a sensor pod on the bottom, which can include camera imaging, and so usually this is described as attacking anti-aircraft installations based on a radar signature. So it's fired, it's launched, I should say, and then it can wander around for several hours over a wide geographical region looking for targets. And when it detects those targets, it can then essentially dive bomb the target. And, but it can also be used not just based on radar signatures, but on visual signatures. So it can be trained, vision algorithms can be supplied which recognize tanks or armored personnel carriers, and then it will attack those instead of anti-aircraft radar. And so this really starts to look like the autonomous weapon that satisfies the definition. So a little bit of history. The history actually goes back a long way. There's a wonderful book, if you're a weapons geek, called Swarm Troopers. You can get that on the web and download it, which goes back even to the 19th century, where people were building various kinds of autonomous weapons. In World War II, the Japanese sent autonomous balloons to set fire to the California forests. So they floated across the Pacific, managing their own height, so they stayed in the jet stream, and then would, when they got over land, they would then descend and set fire to the forest. That was an interesting plan. So this idea has been around for a long time, but in the modern era, it's become much more urgent, to the point where the United States actually issued a very detailed policy governing what kinds of autonomous weapons could be used in the US military and how they were to be managed. And as of now, and for 10 years, so up until 2022, the US is not allowed to deploy or use weapons that have the human out of the loop. So every attack on a human target requires what is called appropriate levels of human judgment. So you can argue about what exactly that means, but that is the policy. And that is the only policy, as far as I know, that's officially in place of any of the major powers on the use of autonomous weapons. So in 2013, Christoph Heinz, who's the special rapporteur for extrajudicial killings, etc., wrote a report about autonomous weapons, and he took great pains to distinguish, I think it's very important up front, these are not drones as they're commonly understood. Drones are remotely piloted vehicles where a human is looking through the camera, deciding where to go, deciding what's a target, deciding when to release the missile. So Heinz went to great pains to distinguish drones from autonomous weapons and to catalog the possible problems that these weapons might have in complying with international law and how they might be used. So I'll get to those issues in a minute. At the same time, a campaign to stop killer robots was announced. This was joint between Human Rights Watch, which is probably the main organization, and a number of other arms control organizations, and then a new, relatively new organization called the International Campaign for Robot Arms Control, which was started by roboticists, Noel Sharkey and others, principally in the UK. So by 2014, the UN had decided that this was a major arms control issue, and there's an organization called CCW, the Convention on Certain Conventional Weapons, which meets in Geneva, and that's the forum for discussing this kind of thing. And so those discussions began in 2014 with the explicit goal of eventually formulating a treaty to regulate these kinds of weapons. And the view was that existing treaties like the Geneva Conventions did not adequately capture some of the issues that they bring up. So at the same time, as all these sort of policies and restrictions and treaty discussions are going on, there's technological development happening very fast. So, for example, in 2015, early 2015, DARPA described one of their programs, the CODE program, which is collaborative operations in denied environment. So a denied environment is one where the enemy is jamming all your radio communications so that you can't directly control your drones, which means they have to operate autonomously. And the CODE program is all about, as they say, every step of the strike mission. And the DARPA program manager forgot to attend the public relations training course, and he described the systems as he wants to build weapons that hunt in packs like wolves. So you can imagine that was widely quoted in the media. So in some sense, while with one hand the US is putting strong restraints, with the other hand, we are pushing ahead very fast with this kind of technology. On the academic side, we've started to have a process that will eventually, I hope, lead to policies from the scientific society. So AAAI held a debate in 2015. Recently, I didn't put it on the slide, but IEEE formed a subcommittee for autonomous weapons, and we are in the process of formulating a policy which will be voted on by IEEE executive. And in 2015, and this was widely publicized, there was an open letter from AI and robotics researchers which explained what we saw as the issues and suggested that we really did need a treaty. So that letter had, as of now, 3,105 AI and robotics researchers who signed it, coming from 50 countries. Most of the presidents of AAAI who are still alive have signed that. The presidents of IJCAI, one of the presidents of the IEEE Robotics and Automation Society, and other famous people, including Steve Wozniak and Elon Musk, Stephen Hawking, and so on. So in the media, and there was a huge media response, about, as of now, almost 3,000, this is a little old slide, but almost 3,000 newspaper articles in response to this open letter and the subsequent debate. And almost all of them say, you know, Elon Musk and Stephen Hawking call for a ban on killer robots or something. That was a typical headline. You know, and then somewhere down the article they mentioned that some AI people might have signed it as well. But that's the price you pay for having famous people, because without them we wouldn't have the newspaper articles. But you know, one very important step was that the Financial Times editorial came out very strongly, actually even more strongly than the letter, saying that this technology is something we absolutely have to stop. And you know, at the same time, things are moving ahead very fast with the DoD. So the 2015 budget request was described this way. So this is for 2017. And Robert Work, who's the Deputy Secretary of Defense, gave several interviews where he basically dared Russia and China to try to keep up with the US in this. He's really sort of scaring them into an arms race. And the World Economic Forum has taken up this issue, so now it's one of their two main global security issues, along with cyber warfare. And that's a very useful organization because they can bring, you know, defense ministers, prime ministers, presidents, Secretary General of NATO, those kinds of people together in a room to have a private discussion, which would be impossible in any official or more official forum. So the DoD now seems to be sort of leaking stuff on a regular basis. So last month they talked about their drone swarm technology. They actually released video of a fighter aircraft launching in flight at 450 miles an hour, launching hundreds of micro drones, which sort of drop out of these pods and then open up and start flying. So they really are, I think, as I said, daring our competitors to get into this race. There's a very interesting report came out from the Center for a New American Security. So this is written by Paul Shary, who was actually the principal author of the 2012 Department of Defense policy that I mentioned earlier, that puts a moratorium on the use of autonomous weapons. So he describes some of the risks that I will get into later on. And then next week, there is another meeting going on in Geneva on this topic. Okay, so that's sort of the situation. So there are diplomatic efforts going on, there are policy efforts, and then there are technological developments that are just moving ahead very, very quickly. So let me just briefly say, to avoid any confusion, what we mean by autonomy. So I was surprised when I went to the CCW meeting last year. Many of the ambassadors who were charged with formulating their national policy think that autonomy means that somehow the machine decides by itself what it wants to do, and by itself that it doesn't like the enemy, and it sort of just takes off of its own accord and goes and attacks people. And so we had to disabuse them of those notions. So these slides, very, very simplified, but to point out what we mean by autonomy. So you've got a human and a robot. That's the human. That's the robot. And the human says win, right? And if this was chess, well, it would be we wouldn't be having this discussion, right? It's obvious that chess programs have a degree of autonomy that allows them to locate enemy pieces and decide which ones to eliminate, right? That's straightforward, right? There's a chessboard, and it does its look-ahead search, and it chooses pieces to take and takes them, right? So that's the only notion of autonomy that we need for autonomous weapons to be a major issue, right? Nothing more than that. We don't need them to learn. We don't need them to formulate their own goals and so on. We just need that they are able to do this without the human supervising each step of the process. And if you go from chess to war, right, it's from an AI point of view, it's just a series of qualitative generalizations of the chessboard, to include partial observability, uncertainty, more than two agents, and various other things. But these are all technical expansions of the problem that don't change the basic notion that we can build AI systems that are autonomous and operate on the field of battle just in the same way that chess programs do. So this leads to the conclusion, actually, and I don't need to make it myself, the UK Ministry of Defence made this, that these weapons are perfectly feasible now for things like submarine warfare, for air-to-air combat, and so on, where it's, you have a relatively clean environment, so to speak, and will be feasible soon for more complicated settings like urban warfare, where there are civilians and so on. So most people I've talked to, defense people in the DoD, people in defense industry, robotics researchers, think that if we really wanted to field complex urban warfare systems that could do things like this, like clear an underground complex, or do sort of border monitoring and repelling any attacks along a border, or even just wiping out, for example, everyone wearing a yarmulke in Israel, that this could be done within a couple of years if you put a big effort with a lot of engineers and scientists on it, as we did with the Manhattan Project. So let's just look at some of the pieces. Right, so low-level motor control is pretty well in hand. So this is something that most of you have seen, just to show you that leg locomotion is a pretty well solved problem. There's now a similar video to this with a bipedal, so a humanoid robot, the Atlas robot, which you can find yourself on the web. It's more painful to watch because they push the humanoid over and make him bang his head, and it's sort of painful to watch that. Systems can navigate pretty well. You can buy chips from Mobileye that will process vision and LiDAR signals in real time and keep track of where you are relative to buildings, the edge of the street, pedestrians, other vehicles, and even deer, and do that pretty reliably. And notice that for autonomous vehicles, we're talking about systems that have to operate at 8 nines of reliability. An autonomous weapon has to operate at not even 1 9. If it's 60% reliable, that's pretty good for a military system. Okay, and they're entirely expendable. If it works 60% of the time, that's great.
Navigate in environments with obstacles.
So here's some work. This is from DJ Kumar's lab at Penn. So imagine this is your living room. Some robots. You can have systems that are able to go into an unknown building, and as they move through it, to build maps of that building in real time. Sorry about the sound. commercial. But there you see the small quadcopter going into the building, and as it goes in, it's building this 3D map of the building. It's going into the back hall. Now it's going to go upstairs to your bedroom. And okay, so we've got all the basic navigation, mapping, threat detection capabilities, target recognition. Already there are vision systems that are extremely good at recognizing various categories of objects and doing face recognition of individuals. So people are now thinking about using these systems to assassinate individuals. You just upload a database of photographs and you say, go out there, find anyone who looks like any of these people and kill them. And so it's giving pause to the Secret Service, who have to defend the president and the vice president and various other people, because it's extremely hard to defend against multiple autonomous vehicles that might be attacking from above. So I'll talk briefly in a minute about engagement, which is the euphemism for killing. And then the tactical and strategy planning. So this is something that is not that dissimilar from what people are doing now for strategy games like StarCraft and Warcraft and military logistics problems. So this is in some sense, a toy illustration, but just showing multiple quadcopters assembling a small building. So you can build complicated plans and have machines like this execute them fairly easily. Right, so that's some technology background. Now let's talk about the legal issues. So here is your 10-second course in international humanitarian law. So oddly enough, right, it is legal to kill people in warfare, and there's an elaborate history going back even to ancient Greece on why it's legal to do that. It's a sort of generalized form of self-defense, basically. And, but it is highly constrained by these three principles. So discrimination, you have to be able to discriminate combatants from non-combatants. And there has to be military necessity for the attack. So even if they are combatants, if they are running away and they've basically given up, you can't just mow them down. That's against the law. And there has to be proportionality. So you're allowed to kill non-combatants by accident, but the collateral damage has to be proportionate with the value of the military target. So you can't kill 1,000 people just to eliminate one enemy soldier. So these are the principles that govern military operations. And so in contrast to the operational requirements that you be able to zoom into a city and zoom into buildings and find people and blow their heads off, these are probably much more difficult from a technological point of view. And as you get more autonomy, these decisions become more difficult. So a cruise missile doesn't have to worry about these because a human has decided that at that particular GPS coordinate, there is a legitimate target, and it can be destroyed without too much collateral damage, and so on. But once you concede some autonomy to the system, then it's going to have to make those decisions for each of the attacks that it launches, and they become more and more difficult as the scope grows. There's also another set of rules which are much more general and vague. It's, they go back to something called the Martens Clause, which is there deliberately as a kind of a catch-all, so that if people develop weapon systems that are just heinous, then the law already precludes them, even though the law didn't anticipate their existence in that precise form. So it says that the human person is protected by the principles of humanity and the dictates of public conscience. So it was things like poisonous gas and disease agents, which are just seen as so disgusting and depraved that we just don't want to allow those things to be used in future. And you can see the effects of this in some of the statements by ambassadors at the CCW last year. So Germany said that doing this is unacceptable. They're never going to cede the decision over the life and death of a human to a machine. And this is, in many discussions of this issue, this is being raised as a potentially new moral principle that we just have to adopt, almost like an 11th commandment. And Japan said something similar, that if you take the human out of the loop, then you're creating machines which can commit murder, and that's not something they will ever do. Maybe most significantly, at the debate in Davos at the World Economic Forum this year, the chairman of British Aerospace was on the panel debating autonomous weapons, and we were expecting a knockdown, drag-out fight between him and the arms control people. But he basically surrendered immediately, or perhaps just took the honorable course and said that his company will never develop these weapons with the human out of the loop because that's a fundamentally wrong thing to do. And they're the second largest defense manufacturer in the world. So that was a quite significant thing to do, and it opens up a sort of a new front in this debate that we may be able to get corporations to band together and declare that as an industry they won't do this. Now the problem with the Martin's Clause is that at the moment we don't have enough public awareness to say that the dictates of public conscience disallow the development of these kinds of weapons. In fact, when you ask people, it is about 70% to 30% in favor of banning autonomous weapons when you ask the U.S. population. But it's very fragile because you can change the way the question is asked. For example, if you ask, would you rather send robots to defend the U.S. or send your sons and daughters? People say, oh, yeah, of course I'd rather send robots, right? So it's not a very robust understanding out there of what the issues are. But I think as a practical matter, if you look at what happened to public policy in Europe as a result of one photograph of a 3-year-old Syrian boy drowned on a beach, right? Now, I imagine that instead of drowning on the beach, he had been chased down that beach by a flying robot that blew his head off. Just to think about what effect this would have on public opinion. I believe at that point there would be very widespread outcry, and governments might be asked, why didn't you do something about this earlier? But at that point, of course, it's too late, because once these weapon systems are out there in very large numbers and they're integrated into the armed forces, it's very hard to undo. So my estimate of what's going on in the CCW is pretty much everyone agrees to this extremely vague formulation that there should be meaningful human control over attacks. But this is, for many countries, I think, an excuse to just leave it at that, because then they can say, well, of course, it's very difficult to say what we mean by meaningful human control, and then we'll talk about it next year. And this is probably going to happen again next week. It's not to me, it's not the best basis to have this discussion, right? So the discussion has been going on about compliance and about this sort of moral issue. And unfortunately, compliance, the feasibility of compliance with international law is going to change. Systems will get better at discriminating competence from non-competence. They will be able to decide on proportionality and necessity. And so it would be hard to base a policy on the risk of non-compliance with law. And in my view, this kind of misses the point. So this is the mental picture that most people in the debate have, that right now we have a human remotely piloting some drone and firing missiles, and what we're talking about is, should we replace that human with a robot doing the same thing, right? So there's always this sort of one-for-one replacement mental picture. And that's kind of silly, right? It's like saying, okay, there's a guy with a spear, and we're going to take that spear and replace it with a cruise missile, but nothing else will change. So he'll still be using it to kill people who are 25 feet away, and he'll still be looking them in the eye and all the rest of it. No, that's not what happens. When you have a different weapon, it gets used in different circumstances. And to me, that's the most important thing about these weapons, is that they completely change the military equation in a very important way. So here's the core of the argument, right? So we can build autonomous weapons, even very tiny ones. So my son has a quadcopter that is about 2 inches in diameter and weighs less than half an ounce and costs less than $10 retail. So my guess is the wholesale price of these is probably 75 cents to $1, almost certainly manufactured in China. And even that device is enough to kill or disable a human being. So it's hard for that thing to carry a machine gun. Right? A machine gun weighs about 28 pounds. And so you're not going to be able to do that. You can carry machine guns on quadcopters that are this big, but that's probably not worthwhile. But you can still have very, very small guns that can shoot people through the eyeballs. The eyeballs are the most damage-prone part of the human. And you don't need a very large bullet to damage someone's eyeball. And if you do a calculation, you can shoot someone through the eyeball from 30 meters away, even if that person is running at full speed. And so this is a pretty effective way of eliminating people, and suggests that we should all be investing in companies that build bulletproof sunglasses. Another thing you can do is you can carry a very small shaped charge, and this was actually a surprise to me. I did some very macabre research on the web about how can very small things kill people. And I should mention that, of course, you could inject them with poison, but that's banned by the Chemical Weapons Convention, so you can't do that. But you can blow a hole in their head with a shaped charge. And it turns out that 1 gram of high explosive in a shaped charge, HMTD explosive, is enough to blow a hole in 9 millimeters of steel plate, which is somewhat counterintuitive, but is in fact true. And if you have a fist-size shaped charge, you can blow a hole in 2.5 feet of steel plate. So these shaped charges are incredibly powerful. They produce directed jets of metal going at Mach 20, and that's what blows the hole in whatever they're standing next to. So you can have very, very tiny things that are able to kill people. And you can put about 1 million of those things into a truck. And so they could be used to wipe out a medium-sized city or a large infantry force or any other kind of target that you might like to attack. And if you just have enough money, then you can do this, right? And this is different from the situation. You might say, well, a million machine guns can kill lots of people too. Yes, that's true. But to have 1 million machine guns kill a lot of people, you need 1 million people to carry them. To have 1 million people carrying them, you need 5 million people to supply and transport and feed and so on those people. And then you need a whole government to fund that whole thing and a whole people to support that process. So yes, you can do a lot of damage if you're a nation state with a very large army. We know that. And we have a whole international system in place to stop things like that from happening. And it's been pretty successful since the Second World War. But this would be a weapon of mass destruction that's completely scalable. That half a dozen guys with enough money can buy essentially tens of millions or hundreds of millions of these devices and use them to achieve their ends. So they can also be used, and this is something I don't really think about that much, but there are people who are very concerned with the human rights implications, not just military, but the use of these basically to suppress populations by a permanent aerial threat that is basically stationed on a city at all times and can be used whenever the people in power want to use them to suppress demonstrations or even attack individuals. So that seems like, and there are even companies now building these things for applications like crowd control, where they shoot beanbags at people. You can buy these devices right now on the web. Okay, so that's sort of the ground attack weapon of mass destruction argument. There are separate arguments that apply in submarine warfare and air-to-air combat and so on, where civilians are not involved, where it's relatively clean, military to military conflict. And in those situations, it's absolutely clear that autonomous weapons have enormous military advantages. They can be much faster. They can have much higher accelerations. They can have much faster responses in terms of being able to avoid attack or respond to movement by the opposition, and so on. So they're going to be, if developed, superior to manned weapons in almost all circumstances. But they have an enormous weakness, which is that their superiority is dependent to a large extent on their software, right? On the AI that's deciding where to go, when to attack, how to group together to apply superior force, all those kinds of things. And so you might think that, okay, we have this amazing force and now we have military superiority. Your enemy could do a software upgrade and gain superiority over you overnight or even in the space of a few seconds. And so you are never sure, unlike the case with sort of, where we're just talking about physical and human assets, where it takes decades to shift from a position of superiority to a position of inferiority. Hacking is obviously something you have to be concerned about. We've not yet succeeded in making a hack-proof anything. And of course, if the enemy finds out the algorithms that your weapons are using, then they can design algorithms that outwit those because they already know in advance how the weapons are going to behave. Even worse, they could modify the algorithms that your systems are using so that they malfunction or even attack you. And this is something that the military are very concerned about. Another possibility, which is quite serious, is that weapons that are designed to respond to attacks could become confused, as has happened several times in the past with our nuclear defense systems. And you could very quickly have a conflict that's spiraled out of control because the decision-making cycle of these weapons is in milliseconds as opposed to days for standard military operations. Finally, I guess the requirement for adaptation in behavior is crucial, right? If your tactical algorithms don't adapt and don't change their behavior, then the enemy will learn how to predict their behaviors and will defeat them. And so they have to be adapting continuously, which means then that it's very hard to know how they're going to behave in any real conflict. And military people don't like that property of autonomous weapons. So as I mentioned, there's a report from the Center for New American Security, which you can download on the web, that goes over a lot of these risks for military-to-military conflict. So I guess I'm getting towards the end. So let me just go quickly through some of the major counter-arguments to what I'm proposing, which is essentially a ban or severe restrictions on the deployment and use of these weapons. So the one that I'm hearing most often talking to people in the military is that we need a third offset. That so our first offset was tactical nuclear weapons for use to deter massive Soviet aggression. The second offset was high precision, rapid decision cycle weapons that can destroy essentially anything that we can see. We can just blow it up, and that's been very effective in a lot of conflicts. But everyone sees that our superiority in that area is evaporating. And so we need a third offset, and a lot of people say, oh, we have really great robots and AI people, and so this is going to be our third offset, which will maintain US military superiority for the next few decades. So I think that's an interesting idea, but it's, in my view, we may not have dominance for very long. Right now, the best quadcopter manufacturers are Chinese or Swiss. And the AI part of this is really not that complicated. Okay, so I am not sure that the US would have, or even has now, a significant lead in this area. And, right, if your strategic security is possibly going to evaporate in seconds and can be completely rendered inoperable by one guy hacking on a keyboard, then that might not be the best way to base the future security of the country. Another counter-argument is that since these weapons are relatively low-tech, we can't stop them from being produced, and therefore we have to have them as well. And I think this is a very serious argument, right? Proliferation is a very, very important part of any weapons treaty. Is how do you enforce it? How do you verify it? And how do you counter any violations of the treaty? So the way it works with chemical weapons, which are actually even lower tech, so the materials you need for chemical weapons are just bulk industrial chemicals that you can buy by the 50 tons. And you essentially just mix them together at the right time and load them into shells and fire them. So it's very easy to do. And for that reason, the chemical industry actually keeps track of all of those precursor chemicals. And they have to certify the purchases. They report all of those sales to the people who, so I think it's the Office of Prevention of Chemical Warfare, OPCW, which recently won the Nobel Prize. And that's an extremely important part of the treaty. There was no such mechanism in the Biological Weapons Treaty. And in fact, the Soviets did violate the Biological Weapons Treaty for more than a decade after they signed it. So this would be a very important step that the relevant industries, which include quadcopter or drone manufacturers, probably people in the 3D printing business, so people selling 3D printers need to keep track of what their printers are being used to produce. And we may need to also track software as well if that's possible. So those are difficult questions, but I think they're feasible. I don't think we're going to be able to prevent ISIS from launching 50 or 100 weapons. But if you're going to launch 50 or 100 weapons, you might as well remotely pilot them, because it's not hard to get hold of 50 or 100 pilots. It's hard to get hold of 1 million pilots, and it's the 1 million weapons that you really have to be concerned about. It's also worth mentioning that countermeasures against autonomous weapons are not banned. So you can shoot down as many autonomous weapons as you want with autonomous weapons, because that's not lethal. There are no humans in these weapons, and so you can blow them out of the sky as autonomously as you want. So the treaty wouldn't prevent you from doing that. And lastly, something that I see a lot in lay conversations about this, so newspaper comment sections and various public debates. People love the idea that no one needs to die, right? We can just have robots fight it out to see who wins. And then somehow we say, okay, I guess your robots won, so great, we will be your slaves for the rest of time. You can pillage our cities and whatever else you want to do. Unlikely that that would happen. In fact, of course, we could just say, oh, let's play Tiddlywinks, and whoever wins the Tiddlywinks match gets to pillage our cities and so on and so forth. But we don't do that because we don't want our cities pillaged, and that's only going to happen when we've exhausted all possible means of defense, and the government simply cannot function to protect its people anymore, and so on. So this is simply a non-starter. Okay, so in summary, autonomous weapons, despite their many attractions from a military point of view, form this new class of weapons of mass destruction that are fundamentally scalable, right? There's a fundamental disconnect because of autonomy between the number of humans you need and the number of weapons you can deploy. And that's what causes the problem. They also have needs. They meet a lot of needs for dictators and terrorists, which we don't necessarily want to encourage. And for the reasons I mentioned, they don't encourage international stability, because the more uncertainty you have about whether you have an adequate defense or whether you have a strategic superiority, the less stability you have in the situation. So for these reasons, I'm proposing a treaty And I guess I was just talking to the White House this morning, and so a group of the signatories of the earlier letter are going to go to Washington and meet with defense officials and start this conversation. So with that, thank you for your attention. Questions?
Are there any, let me back the microphone. There should be a microphone here.
Question over here.
You mentioned the Soviets cheated on the biological weapons convention. What enforcement provisions were in your treaty?
So I'm not really a treaty engineer, but when you look at the Nuclear Test Ban Treaty, it actually, the enforcement mechanism includes the option for the international community to invade 1,000 square kilometers of territory in the country that is suspected of violating the treaty. That's a very, very strong enforcement mechanism, because then they would also dismantle the testing facilities and so on. I think probably similar to the Chemical Weapons Convention, where the international community agrees to enforce, right, that by military force, you have to give up these weapons and verifiably destroy them, or we'll take military action. That's what happened with Syria. And as far as we know, they did get rid of most of them.
Hi. I have like two questions. I saw like in your presentation that first all the strategical like security can be evaporated within seconds by software updates, and I'm kind of curious about your opinion on the role of hardwares in the period where softwares can change in drastic speed. My impression is that in that kind of environment, I think hardwares kind of would come as a key, because some enormous difference in the hardware specification can probably overwhelm the software updates kind of expected in the future. And second of all, another thing is you said in your presentation, I saw that IHL kind of requires any weapon to discriminate between non-combatants and combatants on the warfield. So I think that problem can be handled with the ongoing research on brain-computer interfaces and the microchips, implantable microchips. So I'm kind of curious about your opinion on it, the administrative use of those implementable chips technologies.
Okay, so the first question is about the hardware versus software, and I would say generally software changes more quickly than hardware capabilities. So, when you look at, for example, the history of fighter aircraft, for most of the Cold War, the U.S. and Russia had physically comparable fighter aircraft in terms of speed and agility and so on. The big difference was really in the avionics, actually. So the targeting, the ability to fire missiles even when you're out of visual range, and things like that. So it's possible that one side might develop and deploy a new type of hardware which gave a very different range to weight ratio. Right, so one of the biggest problems when you have very small things, it's hard to give them a very long range, and someone might find a better way of doing that. But typically those things take longer to develop. They're telegraphed in the scientific literature early enough that we can anticipate them and so on. So I don't see, I don't see major hardware surprise as being all that likely. But I think software surprise is quite possible. The second question, discriminating between competence and non-competence, as I said, I think that's probably quite, or I should say increasingly feasible. I mean, there are still corner cases where current vision algorithms would almost certainly get it wrong. But as I said, I don't think that's the core of the argument, right? So arguing about, well, you know, human soldiers in this situation are only 83% reliable, and you know, the algorithm is 74% reliable, but you know, in 10 years' time, it's going to be better than that. That isn't an argument that's, I think, central to this. To me, the argument is a strategic one, that you're creating a class of weapons that will get used in ways that we don't want. That would be catastrophic for civilian populations in particular. And the people who will use them don't care tuppence about the difference between competence and non-competence. So they won't even have a discrimination algorithm at all.
Because of timing, we'll have just one last question.
Okay.
Thank you, Dr. Russell. I just wanted to ask that how applicable are the international humanitarian laws to domestic police departments who tend to be militarizing very much along these lines of automation?
That's a great question, and the answer is they're not. So these come from the Geneva Conventions, which specifically apply to international warfare, right, interstate conflict, and there is no chance that the U.S., as far as I can tell, would ever allow that kind of international treaty to apply to its domestic policy. And this is something that Amnesty and Human Rights Watch are very concerned about. And as I mentioned, there are companies selling, you know, quadcopters or hexacopters, you know, armed with beanbags or tear gas that can fly above crowds and selectively target individuals.